Hello, this is a short video giving you hints on solving the assignment for week 6. Week 6 assignments involve the Fourier transform, and you need a basic familiarity with the definition of the Fourier transform, but most importantly you need the familiarity with the table of Fourier transforms and table of properties for Fourier transform. These two tables are quite important. We will use them very actively in solving any problem that we face. Okay. So, here is the questions for week number 6, and if you look at the first question, okay, it gives you an f of t which is e power minus a t times 2 sin squared omega c t u of t, and asks you to find the Fourier transform for that. Okay. So, like I said, an important thing that you will need for solving such problems is a table of Fourier transform pairs and a table of Fourier transform properties. I have one such table with me. You might have another table. The books carry a pretty good table. You have to use that table quite extensively. Okay. So, if you go in and look, here is a table that I have. If you go through these things and the properties come first in this table, it tells you what happens if you do f of t minus t naught, what happens if you do f of alpha t, so on. Okay. So, all these things, what happens to the Fourier transform is there in this table, and it also has a list of Fourier transform pairs. Okay. So, for instance, delta of t maps to 1 in the Fourier transform, e power j omega naught t goes to 2 pi delta omega minus omega naught. Okay. So, you need to have a table, and you also need to have some basic familiarity with these transform pairs. In case you do not have the table with you, you should know the standard pairs quite easily. Okay. So, in fact, many of them can be derived, and maybe I will show you how to go through some derivations. But for this specific problem in hand, okay, look at the problem once again. Let us look at it once again. This is the question, and the question says I need the Fourier transform for e power minus a t times 2 sin squared omega c t u of t. Okay. Now, if you go through the table, I seem to have a Fourier transform pair which is kind of close to this, but except that you have e power minus a t cos omega naught t. Okay. It does not have sin squared or something. Okay. So, the hint for the first question is to take this problem here and convert this signal, I am sorry. So, the hint for the first question is you take this signal and convert it into a form which is like e power minus a t times cos. Okay. So, you can use a trigonometric identity for that to do this. Okay. But I also should warn you, this is not the only way to solve this problem. There are very many other ways in which you can solve this problem. The other way would be to use the property of multiplication of two signals. Okay. When you multiply two signals, the Fourier transform, there is a property for the Fourier transform. If you go through and see it, for instance, product of two signals, okay, so that does not seem to be captured here. Let me just look. Okay, so it is not there in this guy. Okay, so let me just remind you what that property is. There are other tables which might give you these properties. There is this important property of the product of two Fourier transform pairs. So, this is once again week 6, and question number 1. You might want to use this property, x of t times y of t transforms to 1 by 2 pi x of j omega convolved with y of j omega. You can also use this property to solve the first problem. Okay. So, I would not recommend it. It's probably a longer way of solving the first problem, but the first problem, the easiest way is to use a trigonometric identity and convert it into standard form. Okay. So, that is one. Let us move on to the next question. So, here is a question. This is a very typical sort of question to use properties of Fourier transform. Here is a signal f of t that is given to you. Okay. So, it is a triangle kind of signal. It starts at 0 at time 0, goes to a at time t by 2, and then comes back to 0 at time d. Okay. So, this is a triangle, except that it has been shifted right by d by 2. Okay. So, you might know the Fourier transform for the triangle which is not shifted right, okay, which goes from minus d by 2 to d by 2. Okay. You might know that. Now, you have to rewrite this function using that other triangle. That other triangle usually is there in the tables. So, if you look at for the second question, if you have a signal like this, okay, minus d by 2 to d by 2 a, for this you might find the Fourier transform from tables. Okay. So, all you have to do is to write this other function you have here in terms of the triangle with the center at the origin, and then you will get the answer. Okay. So, it is a typical application of Fourier transform. Let us move on to the third question. The third question is the direct application of the time shifting property. G of t is f of t minus tau. You go to the table of properties, there is one property that will immediately apply and you can use that. Okay. The same thing goes with 4 also. Okay. So, it is a standard question. This is in fact, actually this is listed in one of the properties, the fourth question, f of t as Fourier transform f of j omega, f star of minus t would have a standard. Actually, f star of t maybe is directly listed, but then for f star of minus t, you have to figure out how to combine those two properties. What happens when you transform, when you conjugate, okay, when you do f star of t, and then what happens when you do f of t to f of minus t. Okay. So, that is how you do the fourth question. For the fourth question, you have these two properties, x star of t transforms to x star of minus j omega, and x of minus t transforms to x of minus j omega. Okay. So, now the question asks you to find what happens when you do this. Okay. So, it is just a combination of these two properties and you should be able to solve problem 4. Okay. So, like I mentioned, many of these problems are very simple combinations of applying the basic Fourier transform properties, and if you are not used to it, it will be a little bit new the first time you do it, but as you get used to it, you will see, you will be able to quickly see what properties you have to use. Okay. So, here is another question. F of t is as shown below. It's actually a rect signal, a rectangular signal. It starts at minus d by 2, goes up to a, and then falls back down to 0 at plus d by 2. Okay. And you are not asked for the Fourier transform of f of t, which you might know is some sinc function, but you are asked for e power j omega c t times f of t. Okay. So, now we have to use the table for f of t, and then you have to use the property which is for e power j omega c t multiplication. Okay. So, in fact, this is a property that you have to use for the fifth question. E power j omega naught t times x of t transforms to x of j omega minus omega naught. Okay. So, you apply that, you are going to get the answer. Okay. So, fifth question is quite straightforward. Many of the questions in this assignment are simple straightforward applications of the properties that you know. If you are comfortable with that, you would have no issues. Okay. So, here is another one. Okay. F of t has Fourier transform f of j omega. What is the Fourier transform of e power j omega c t? Instead of just asking e power j omega c t times f of t, you have done t minus tau. Okay. So, now you have to combine two different properties. You use this property for the sixth question, this one, and the time shift property, x of t minus tau goes to e power minus j omega tau times x of j omega. Okay. So, you combine these two properties, you will get the answer for the sixth question. Okay. So, like I said, instead of just asking you one property directly, we would like you to combine two properties, so that you get familiar with both of them and see how the form looks. Okay. Okay. So, here's another question, question number 7. So, instead of asking once again, so f of t is a Fourier transform of f of j omega, you are now asked for the double derivative. Okay. So, if you differentiate once, we know what will happen. So, how do you get the double derivative? You take the different derivative and differentiate again. So, you have to use the property of the derivative 2 times. Okay. So, that is all. The derivative property is quite easy. The derivative property is d by dt x of t transforms to j omega x of j omega. Now, you take this guy and differentiate again and use the same property, you will get the answer. Okay. So, it is an easy application. You have to just pay attention to the details in making sure you do not miss the minus sign or the j or something. Okay. All right. So, okay. So, the eighth question is a direct application of the energy and the Parseval's relation for signals, and you have to pay attention to the constant there, whether it is 1 or 1 by 2 pi shows up, etc. But this is a standard definition. I am going to not give you any more hints other than that. Okay. So, let us move on to the ninth question. Ninth question is also quite straightforward. You, in most tables of Fourier transform, you will find the Fourier transform for e power minus mod t. Okay. You will find the Fourier transform directly listed. You can just go there, use that thing and substitute omega equal to 1, you will get the answer. Okay. So, it is a straightforward question. And the next question is about a signal whose Fourier transform is e power minus 2 omega for omega greater than or equal to 0, and it is equal to 0 for omega less than 0. You have to find the energy of the Fourier transform, energy of the signal. Now, you can use Parseval's relation and use the definition for the energy in terms of the Fourier transform, and it will be a very simple integral that you have to do, and you will get the answer. Okay. So, this is more or less an integral question, the 10th one. You have to use a very simple integration. Okay. All right. So, 11th question is once again using two properties, f of t to f of j omega. What is the transform for g of t, which is d by dt of f of minus 2t. Okay. So, you have to, your first property you have to use is f of, there are two properties you have to use for the 11th question. X of a t transforms to 1 by mod a. Remember the mod, you should not forget the mod, j omega by a. Okay. And then the other property is actually right here, the derivative is j omega times x of j omega. So, you take this, then use that property. So, multiply by j omega. First a is equal to minus 2 here in this problem. Okay. Let me just ensure that I got that right. Yeah, a is equal to minus 2 here, and then you plug that in, and then you do the j omega multiplication, you are going to get the answer. So, you use these two properties together, the derivative and the scaling property, you will get the answer for the question. So, like I said, it is mostly straightforward application, but nevertheless pay attention to the constants, be careful about the numbers. Okay. So, now here is a signal f1 of t, which is e power minus root 3 a mod t. Okay. Now, the available energy in the signal is of the form 1 by a root x, what is the value of x? This is again a straightforward integration problem. I do not want to go into the details. You use the definition of the energy of the signal, which is the integral of mod absolute value of f1 of t squared. This is just an exponential. So, the squaring will get rid of the t. You have to just use a very simple integration after that. Okay. The squaring is going to make it e power minus 2 root 3 a mod t. Then you have to integrate that from minus infinity to infinity. It is a straightforward integration, you will get the answer. Okay. So, I am going to skip giving any more hints for 12. Let us go to 13. Okay. So, the 13th question tells you that there is a filter. Okay. Filter is just an LTI system with a certain impulse response. Okay. And when I say h of j omega inside a box, that is a Fourier transform of the impulse response, and that is given to you. Okay. And the signal f of t is 1 by 2 pi sinc t by 2 pi is passed through the filter. Okay. What is the ratio of the output energy to the input energy? Okay. So, these kind of questions can be solved in the time domain or in the frequency domain, depending on convenience. Okay. So, now f of t is 1 by 2 pi sinc t by 2 pi. What is going to be its Fourier transform? The Fourier transform is going to be a rect signal. Okay. A rect signal is considerably easier to integrate than a sinc signal, right. It is very easy to integrate a rect. Okay. So, you might want to solve this problem entirely in the Fourier domain. Okay. From f of t, you go to f of j omega, and then that is going to be a rect. Okay. There will be some scaling factors, pay attention to that, but it is going to be a rect, and you can integrate that to find the energy before filtering. Okay. So, let me write that down for the 13th question. Go from f of t to f of j omega. This will be some rect signal. Okay. So, you integrate this to find, square and integrate this, integrate to find energy. Okay. So, that is the input energy. Okay. So, let me write that down a little bit more clearly. find input energy. Okay. So, to find the output of this output of this filter, we know that the output will be something, but the Fourier transform of the output is going to be f of j omega times h of j omega. Okay. So, this is the ft of output. Okay. Both of these are rects, and when you multiply you will again get a rect signal. Okay. This guy is also a rect signal, and you can once again square integrate to find output energy. Okay. So, find output energy by squaring and integrating. Okay. So, these are easy things to do, and if you follow these steps you will get the answer quite easily. Okay. So, that is the hint for the 13th question. Let us move on to the 14th question. So, the 14th question gives you an integration. I of a is integral from 0 to infinity sin of a theta by a theta d theta, where a is not 0. Which of the statements is true? In fact, integral 0 to infinity for sin theta by theta d theta is given to you. Okay. So, you have to use that and figure out what the integral for sin a theta by a theta will be. Okay. So, one thing I will tell you. Okay. So, this is given to you, integral 0 to infinity sin theta by theta d theta is given to you. Okay. So, all you have to do is make the substitution theta prime equals a theta. Okay. If once you make that substitution, you will get the answer for integral from 0 to infinity sin a theta by a theta automatically. Okay. So, the substitution is quite straightforward. You do not need to use any more fancy methods than that for this. Okay. Now, the 15th question is a rect signal. The rect function is given for you just for reference, and you are asked to look at a sinc signal x of t. The Fourier transform of the signal is given to you. What are the values of p and q? Okay. So, this is just a direct use of the table. Okay. So, you have to go to the table will give you the sinc to rect conversion properly. So, now on the other hand, this x of t is sinc. Okay. So, you might want to use the duality property in case your table does not have it. You might want to use the dual property. What is the dual property? It is an important property to know. Yeah. So, if f of t transforms to f of j omega, capital F of t transforms to 2 pi small f of minus omega. Okay. So, this is called duality. Right. If you go from time domain to Fourier domain, you take the Fourier domain function and use t instead of j omega, you will get a time domain signal. For that time domain signal, the Fourier transform is again the same time domain, initial time domain you started with f of t, except that instead of t you put minus omega multiply by 2 pi. Okay. So, if your f of t is a rect, you will get a sinc. Okay. Now, how do we find sinc here? If you put a sinc here, you will get a rect. Okay. So, you can use this and figure out what is the Fourier transform of a sinc function. Okay. And you have to use this property closely, we will figure out the constants. Okay. So, that is the hint for the 15th question, and finally, we are done. We have come to the last question. Okay. The last question is just a simple table. Okay. Any Fourier transform table will give you a list of Fourier transforms, and in them there will be Fourier transform for sine and cos. Okay. You just have to go there, identify which is correct, which is wrong. Okay. And then just pay attention, j times j is minus 1. So, minus 1 by j for instance is plus j, etc. Okay. So, you have to make sure that those kind of mistakes you do not make. Once you take care of that, you will get the answer for the last question. Okay. So, hopefully you got an idea of how to play around with signals and their Fourier transforms. Most of the questions in this assignment are a simple use of properties and basic Fourier transform tables, and by the end of this assignment, I hope that you have got enough experience to be confident of finding Fourier transform for standard functions or functions that are very similar to standard functions. Okay. Thank you very much.